Hi, welcome back to 101 Things. This time I want to talk about some of the changes I've made to the Pi-Pico SSTV project. I've added loads more functionality, including an encoder, SD card support and a menu-driven user interface. Since I first published this project, the most requested modes so far are PD120 and PD180. I think this is because they're the modes used by the ISS for occasional transmissions from space. These were the first modes I added. You can download sample communications from the SpaceComms website. I've added a link in the description. These recordings work really well with the Pi-Pico decoder. We've also added the colour and black and white robot modes. The colour robot modes are quite tricky to implement because they send different colour information on alternate scan lines. Thanks very much to Francisco Capuzzi, who came up with a very clever method to work around this problem. He also contributed this neat waterfall feature that can help you to tune your radio. I originally released the project as an Arduino sketch, but now I've made modifications to the hardware for new features, but I also want to keep backwards compatibility with existing designs. I decided to convert the project into an Arduino library. One of the nice things about Arduino libraries is that you can include examples with them. The first example supports the original hardware and just uses a simple TFT display. The second example extends this to add basic SD card logging capabilities. I've also added a basic transmit example. This example takes images from an SD card and transmits them. There's also a full-featured example. It includes receive and transmit functionality, SD card storage, and a menu-driven user interface. I'm also hoping that the SSTV library can be used in other projects. One great example of this is the Wio Terminal SSTV project by Francisco Capuzzi. This makes a really neat SSTV device, and there's a link in the description. If you've been following progress on the Pi-Pico RX project, you might be interested to know that the receiver now includes a built-in decoder based on this library. One of the most requested features is SD card storage. This makes the device a lot more useful as it allows images to be stored automatically as they are received, which means the decoder can be left unattended. I've left mine running for several days at a time, and I periodically check back to see what's come in. Although it's possible to purchase separate SD card holders, I opted to use the SD card holder that's built into most ILI 9341 displays. A few extra wires are all that is needed to connect the SPI bus to the SD card. I opted to use the SDFS library included in the Arduino Pico core. In addition, the VFS library allows the SD card to be accessed using standard C library functions. For image storage, I wrote a very simple library that allows BMP images to be loaded and saved. The nice thing about SD card storage is it allows images to be stored in full resolution, even if they have to be downscaled to display them on the TFT. Compared to the decoder, the encoder is relatively simple to implement. The audio output is generated using PWM, followed by a filter and a DC blocking capacitor. The PWM audio code has been reused from other projects. The encoder takes image pixels and converts them into tones of different frequencies and durations. The timing of each tone has to be calculated very precisely to maintain timing over long periods. Once I know the frequency and duration of each tone, I can turn it into audio samples using a phase accumulator and a sine lookup table. The audio samples are then sent to the PWM audio output. While the basic examples give the minimal code needed to receive or transmit an SSTV signal, the full-featured example is more complete, including many of the features included in PC-based SSTV software. As well as including both transmit and receive functionality, this example provides a richer experience, including a user interface that allows you to browse files and customize settings. If you'd like to check out the technical documentation, I've added a link in the description. This includes all the information you need, including wiring and a parts list. The full example includes an image browser with slideshow mode. This allows you to navigate or view all your stored images. I've also added a text overlay feature that can be used when you're transmitting. The text overlay feature allows a user-defined text banner to be added to an image prior to transmission. This allows call signs and other messages to be embedded directly in the image. I reused the frame buffer code from the Pico Planetarium project. I've added a link to this in the description. I have also reworked the 3D printed enclosure to accommodate the new hardware. I used the Pico Planetarium enclosure as a starting point. This already includes 4 buttons and a display. I've tried to make the enclosure as flexible as possible and I've included different front panels to support different size TFT displays from 2.4 to 3.2 inches. I've included a cutaway slot for the SD card that can be trimmed to fit any particular display. I've also included customizable features to accommodate power switches and audio jacks. These can all be trimmed to fit using a drill or a craft knife. For portable operation, the enclosure includes a generously sized battery compartment. It's easy to power the Pi-Pico from batteries, and the datasheets gives a few options of how to do this. So, in this installation, the Pi-Pico SSTV decoder has been extended into a more fully featured portable device with support for most popular modes. We've included a menu-driven interface, SD card storage, and an image file browser. I haven't had much luck yet receiving SSTV from the International Space Station, and I seem to keep missing upcoming events. This is something I'd really like to get working, so I'll keep looking out for opportunities. There's still plenty more I'd like to achieve with this project in future. Among other things, I'd like to extend the code to include support for a small camera. I'm also keen to extend the decoder to include other digital modes such as FT8, PSK31 and RTTY. I'd also like to look at designing a CW decoder, so watch this space for more updates. So, if you've enjoyed this video and you'd like to see more, why not subscribe? I've got loads more ideas for projects like this one. Thanks very much for watching, and I'll see you next time.